Now that we have a planet and a player, let's add the movement and another camera. To add the camera, we'll add a child node of the type camera 3D. Let's move it a bit up and a bit backwards. Backwards in Godot is the positive Z, because Godot has a right-handed coordinate system where the y-axis is up. So either x positive would be left or z positive would be back. We can preview what the camera sees with this button and show both our editor and the preview using two viewports. When we press play, however, the camera is not being used. This is because our camera doesn't have the current flag enabled. So when we click on this current flag, we can see that the camera is being switched in our game. But let's switch between the cameras in code using a hotkey. To add keys to a category so that they can be used in the game, we need to edit the input map. There's already loads of built-in actions, but let's create our own. Simply by typing in a name and adding it. By pressing the plus to the right, we can add a key to the action simply by pressing the key. Now let's access the camera we just added in the scene from code. This camera will only be available once the player scene is ready, so we need to use a variable with the onReady annotation. Make it of type camera 3D, and we can just drag in our camera from the connected scene. Now that we have a reference to the camera, we can toggle the current property. Let's use the process function, which gets called every frame. We can use the input function isActionJustPressed to see if our camera button has been pressed, and subsequently set the value to the opposite of the current value. When we play and press our camera button, it will switch between the first and the player camera. Now that we have a player camera, let's make the player move. To get the direction we want to move in, let's create the function getMovementDirection with a variable direction of type vector3 with initial value of 0. Using the input function isActionPressed, we can see if the button is currently being pressed. Then we can add to our direction vector a vector in the direction that we want. We can repeat this for each direction and at the end return our calculated direction. To really move the player, we'll create the move function with the delta argument. By using the delta, we make sure that the movement is frame independent. Let's create a speed export variable for the player. This way we can edit this variable on runtime and play around with the speed until it feels right. Get the movement direction by calling the function we just made, and if the direction is 0, we can return without doing anything. If the boost key is being pressed, we can increase the speed, and to really move the player, we'll use the translate function. Here we'll fill in the direction of the movement times the speed. When we press play and press our movement buttons, we can see the player moves, and when we switch the camera, we'll feel our player move. By pressing boost, the player moves faster, and to change our export speed variable, we can go into the remote tab, where all the currently loaded nodes are displayed, and click on our player. To the right we see our speed variable, which we can change. By changing the speed and without stopping our game, we can see that our player is now much faster.